It's 2015, question 1. This right here is an accumulation problem. We could tell right away because there's some type of rate in and rate out problem. So if you notice, we have rainwater, the rate at which rainwater is flowing into a drain pipe, and we also have the rate at which water is draining out of the end pipe. Okay, so something's going in and something's going out. Okay, and then they give you some initial condition. We'll talk about that later, but let's jump to part A. How many cubic feet of rainwater flows into the pipe during the 8-hour time interval? So we want to know how much is going into the pipe from 0 to 8. Know that this has nothing to do with the amount of water that's draining out. So we only want to integrate R of t, okay, from 0 to 8. When you integrate a rate, you get rid of the word rate, and you're just talking about the amount. That's called accumulation, okay? You pretty much plug and chug here. You should get 76.570, okay? Easy 2 points. Here's part B. Is the amount of water in the pipe increasing or decreasing? So if you want to know if something is increasing or decreasing, okay? So if you want to know if something's increasing or decreasing, you check the rates, okay? It goes back to that example I gave in class with the bathtub, okay? You have water that's pouring into the bathtub and then water that's draining. The only way the water level is going to increase is if there's more water going in than more water that's going out. So you could do this in 2 ways. You could check the rates, R of 3 and D of 3, to see which one is bigger, okay? And that should be able to tell you if the water is increasing or decreasing. Or what the scoring guidelines did was they subtracted the 2. Okay, so here if you subtract the 2, if you get something negative, that means that D of 3 was working a lot faster than R of 3. Okay, if you get something positive, that means that there was more water going in than there was going out. So however you want to do this here, okay? So definitely make that computation and then somehow justify it with the conclusion. Okay? Here's part C. At what time from 0 to 8 closed is the amount of water at a minimum? So here we know we're looking at an extrema. Specifically, we know it's absolute because there are bounds. It's a closed interval here. So some things that we have to get out of the way. If you want to know the amount of water, okay, you have to consider what you started with. So in this case, at t equals 0, I started out with 30 cubic feet of water. Then I want to factor in the amounts that are going in and the amounts that are going out. So where I stop, and I'll just call this X, where I stop is depending on at what value I'm interested in here, okay? So this right here is the amount of water, all right? So if I want to know where the amount of water is the minimum, it could occur at the 2 endpoints, 0 and 8, which is what we have right here, or at the derivative. The derivative of this right here, 30 is going to go away. The derivative of an integral, you're just going to be left with R of t minus D of t. And then we set that equal to 0 because we want to find our critical numbers, okay? So if you have y1 as r and y2 as d, you would just have y3 as y1 minus y2, and then you would just find your zeros. It should occur at 0 and 271. Okay? So you would actually have to calculate your zeros, so you would have to go to second, trace, pick a left and a right bound, and a guess, okay? So here we have it, all right? Remember, the amount of water in the pipe is going to be 30 plus the integral of r minus d from 0 to whatever number you want. So the first one would just be from 0 to 0, but the integral from 0 to 0 is just 0, and you're left with 30. So that kind of makes sense, okay? Now the next one, if you want to find the amount of water at 3.271, you would have to plug in 3.271 up here as your upper bound. Plug and chug, you should get this value here. And same fashion, in terms of getting the amount of water at t equals 8, you would just go from 0 to 8, and you should get 48-ish. So based on this here, we could tell that the amount of water is at a minimum. Specifically, this is the amount of water, but they're asking for the time. So it'll be 3.272 or 271, depending on how you do it there, okay? And your justification is really just your table. So just keep that in mind too, all right? Here's the last one. They tell you that the pipe can only hold 50 cubic feet of water before it starts overflowing, okay? For t greater than 8, water continues to flow in and out of the pipe at the given rates until the pipe begins to overflow, right? But do not solve an equation. So it's pretty straightforward. This is how much you started with, and this is how much you accumulated. And we set it equal to 50 because that's the amount when the pipe starts to overflow. So the only thing you guys have to consider here is that arbitrary upper bound. You just set it to some W. I believe they give you the time W there. So, once you reach that time, it's going to start overflowing. Okay?